In this video, we'll be discussing task parallelism, the most high-level form of parallelism or concurrency, and one of the most important in many applications. In this video, we'll define exactly what task parallelism is. Task parallel problems are those problems which can be solved with many long-running procedures that don't depend on each other's data. One great example of task parallelism is web programming. Web servers accept requests from clients, which are all slightly different, process them, and return a response. This typically involves reading from disk, communicating with another web server, and/or talking to a database. Each of these requests is totally different in terms of time to deliver. Some may take a very short time, like a cached static file request that's already in memory. On the other hand, it may be necessary to connect to a database, do some processing, and then read from disk to respond to a search request, for example. If we waited until each request was finished before processing new ones, we could end up in a very bad scenario. Let's say each cached page request takes 20 milliseconds, while a search request takes 60 milliseconds. If we processed each web request sequentially, it could take as long as 220 milliseconds, and several users have to wait longer than 100. Even if we have the capacity to handle just 2 simultaneous worker threads, we can dramatically improve this. Now, the total time is just 120 milliseconds, and only one user waits more than 100. Task parallelism can be combined with other kinds of concurrency, such as I/O concurrency. For instance, there are times during the search request that are simply waiting for the disk or database. What if we handled a cached page request during that time? Well, even assuming we could only handle a single cached page request during that time, we get vastly improved numbers. Now, only a single user has to wait even a whole 100 milliseconds.